So this is the second lesson on the eye. So last lesson we looked at the structure of the eye, and from the specification we dealt with looking at the different parts of the eye. What we're looking at today is the process known as accommodation. So accommodation is how the eye focuses on both near and distant objects, and this involves changing the shape of the lens. And what are involved in this is the ciliary muscles, the suspensory ligaments, and the lens itself. And then once we've looked at how the eye focuses, how the eye carries out this accommodation, we're going to look at different ways in which we can rectify if people have a problem. So they are either myopic or have hyperopia. And then we're going to have a look at how we can help that and make it a bit better. So let's start by just generally having a look at focusing the eye. Now we're going to have a look at some diagrams today, and those diagrams are going to be very similar, but there are a few subtle differences. So this first diagram just shows you basically what happens to an image when you see it in your eye. So here is the image. So light hits that, the light is reflected, and the light rays pass into the eye. First of all, they are refracted by the cornea, so that bends the light. 2/3 of the light being bent happens by the cornea, and then it enters through the lens, which may do a little bit more. And then what happens is the light rays cross over in the middle of the eye, and they project an image that is upside down on the back of the retina. And then your optic nerve detects that image, sends electrical impulses to the brain, and the brain effectively knows that what you're looking at is the right way up. So this is generally how we focus. So light rays come in, they are bent by the cornea and the lens, and they then project this upside down image on the back of the retina. So this is what this says here. So normal focusing, they're refracted by both the cornea and the lens. The light rays cross and form an upside down image on the back of the retina, and then your brain flips that image up the correct way. But there are two things that we need to have a look at, and that is how we focus when we are looking at objects that are either far away or close up. So naturally, the lens wants to be a sphere, it wants to be spherical. But if we need to change the amount that the light is refracted, we can alter the shape of the lens to allow that to happen. So we can allow it to be pulled into a thin disc shape, and that will allow the light to be refracted slightly differently. So a fat lens, so the natural fat shape of the lens, refracts light more than a thin lens. And the two things that are involved in controlling this, as we've said, are the ciliary body and the suspensory ligaments. Now, hopefully you have either managed to print off this table, or if not, you can draw it out now, draw some rough diagrams. And we're going to go through and we're going to fill in the different parts of what happens to the eye when we're focusing. So we're going to start off by looking at something that is near. Okay, so when we are looking at something that is near, a near object, the light rays that are coming in are spread out more. So they need to be refracted more so that they cross over and focus on the retina. So in order to do that, we need a fat, round lens. Okay, so we need a fat, round lens in order for this to happen. So how do we get our lens, how do we allow our lens to be as fat as possible? Well, that's all to do with the ciliary muscles. So the ciliary body contracts. So muscles always get shorter, and so when a round muscle gets shorter, the circle of muscle gets smaller. That puts less pressure on the suspensory ligaments that are holding the lens, so they slacken, and that allows the lens to naturally bulge out and become a sphere. Okay, so the ciliary muscles contract, suspensory ligaments slacken, and the lens becomes thicker, fatter, rounder, and focuses the light on the retina correctly. When we're looking at something far away, we need our lens to be much thinner. So in order to do that, we need to refract them less because they're coming in much straighter. the ciliary body relaxes. So when the ciliary body relaxes, that ring of muscle gets bigger. This causes the suspensory ligaments to tighten. And then what this does is it pulls on the lens and makes it thinner. And then that allows the light to focus correctly on the retina. So in your table, the ciliary muscle is contracted, relaxed. Suspensory ligaments here, okay, are slack. These ones are tight. The shape of the lens, fatter, rounder, thinner, and disc shape. Okay, so that is our process of accommodation. So one of the reasons why our eyes get tired is that when we're looking at things that are very close, our ciliary muscle is contracted. So that muscle is contracted. That means that muscle gets very tired, and that's why your eyes get tired if you're focusing on things close up for a very long period of time, which is why when you're working, you need to look out the window at something in the distance, and that causes your ciliary muscle to relax and give your eyes a bit of a break. Right, sight defects and their corrections. So sometimes we're not very good at focusing our image exactly on the back of the retina. Sometimes what happens is the image is focused either in front of the retina or behind the retina. So we're going to have a look at, first of all, what we call short-sightedness, or nearsightedness, you might see it referred to, or myopia, to give it its proper term. And basically, in myopia, you can see objects that are very close, but you can't focus on things that are very distant. And that is caused either by the eyeball being elongated, or the distance between so the lens being too thick and curved, so the light is focused in front of the retina. Now, this is where the problem comes with these diagrams that we're looking at. What this diagram showing, this you'd think it was showing that it's a perfect, focusing on the retina because it will be upside down from here. These diagrams tend to show the actual point of focus is here. So we're focusing in front of the retina. So we are short-sighted, our image is not getting to the retina. So what can we do to help this? Well, we can use what we call a concave lens. So with a concave lens, that helps diverge the light out as it comes into the eye slightly, which makes the image move backwards and fall onto the retina. Okay, so if you are short-sighted, you have concave lenses. I don't think you've done lenses yet, but concave means this sort of caves inwards. All right, and that helps diverge the light out a little bit, and it focuses it more on the retina. So the opposite of myopia is hyperopia. So this is long-sightedness, or sometimes called far-sightedness. And basically you can see objects that are in the distance clearly, but you can't focus on near objects. So you become more long-sighted as you get older, which is why you often see people who are slightly older, when they're trying to read something, moving it further and further away from their eyes, because they can see things that are far away, but they can't see things when they're very close. So what causes this? Well, it's too short an eyeball, so your eyeball is too short, or there's a loss of elasticity in the lens, so that's what happens as you get older. And basically what happens now is you end up with this light being focused behind the retina. So the light is now focused behind the retina, not on the retina, so you get a blurry image and you can't see it. So how do we rectify that? Well, we use convex lenses. So convex lenses are these ones that curve outside in both ways. And what happens is they converge the light. So they force the light to come together and move that point of focus from back here to here. So now it's focused on the right place, on the retina. Okay? So you should have a table to fill in to explain what's going on there. Now, other treatments that we can do to help with this, there are 3 other treatments that we can do to help with this. You can wear contact lenses. So contact lenses are basically just like tiny little lenses, so tiny little pairs of glasses. Rather than wearing them in front of your eyes, you wear them on your eyes. And these come in 2 different sorts, hard or soft. They're just made of 2 different substances, and you can keep them in for different amounts of time. And basically they float on top of your cornea, and they act like little tiny spectacles, okay, in your eyes. You could have laser surgery. Now, laser surgery, basically what they do is they remove the front part of the cornea and they zap the cornea with a laser to make it a different shape. So they reshape the cornea so that light is then refracted by the right amount to focus. Or the other thing you can do is you can have artificial lens surgery. Now, there's different types of lens surgery. If you've got an elderly relative who have had cataract operations, that's when the lens becomes cloudy and they take out the old lens and they replace it with a new lens. With this type of corrective lens surgery, they put an artificial lens, you can just about see it here, in on top of the other lens that you've already got that corrects your eyes. The advantage of this is that you can then, you've got perfect eyesight, or nearly perfect eyesight all the time, so you can go swimming with it and do more, without having to put your contacts in or wear glasses, those sorts of things. Okay, right, a few little true or falses just to finish off with. True or false, for viewing distant objects, the lens of the eye needs to be fat. That is false. Thin lens, far away. Viewing distant objects, the ciliary muscles need to contract. That is also false, because you get tired eyes when looking at things closely because it is contracted. Viewing distant objects, the suspensory ligaments are pulled taut and they pull the lens flatter. That is true. A fat lens has a shorter focal length and can focus on near objects. That is also true. If you do close work for a long time, your eyes might ache as the ciliary muscles have been working hard to contract. As I said just now, that is true. When you're asleep, your eyes are accommodated for distant viewing because the ciliary muscles are relaxed. That is also true. Okay, so you're not focusing on the inside of your eyelids, your ciliary muscles are relaxed and they are looking at that. Okay, right, so that is the end of this video on accommodation in the eye and how you can rectify errors in vision.